So, today we're going to peek inside the blueprint for a mind. We're talking about a system that's designed not just to do a task, but to actually learn and get better over time. So, how in the world do you build something like that from scratch? Well, let's dive in. And that's really the core question, isn't it? How do you create something that doesn't just blindly follow instructions, but can learn from its experiences and improve all on its own? This is the fundamental challenge that this whole architectural blueprint is designed to solve. And the answer, the big idea here, is something called Meta-Temporal layered cognition. Yeah, I know, it's a total mouthful. But just think of it like building a brain, layer by layer, where each part learns from the others over time. This is a huge deal because it's the key to making systems that can handle really complex problems that are always changing. And it's all done through a very specific structured process. And that's the blueprint we're going to walk through today. So here's our roadmap for today. The whole construction job is broken down into 5 distinct processing stages. First, you have to identify the layers. Then you get them working on the right timeline. After that, you build in feedback loops, automate the improvement process, and finally, you sync everything up so it works together. We're going to go through each one step by step. All right, let's start where you always should, at the beginning. Any great building needs a rock-solid foundation. And for this kind of cognitive architecture, that foundation is built on 2 absolutely crucial ideas: figuring out the layers and getting the timing right. And that brings us right to stage 1, identifying and defining those cognitive layers. So before anyone writes a single line of code, the architect, which the source material calls phys-la-meta, has to map out the system's basic building blocks. You can think of these like different departments in a company, one for processing new information, maybe another for spotting patterns, and a third for making the final call. Now, here's what's really interesting. The architect doesn't just make these layers up out of thin air. You see that dependency? The whole process relies on a pre-existing workflow structure from another system, which is called Lyra. So right away, we know that even the foundation of this system is being built on top of an even earlier plan. Okay, so once the layers are defined, we hit the next critical step: temporal coordination. Look, it's not enough to just have all the parts, right? You have to make sure they all work together on the right schedule and in the right order. And this is where you really see how logically this whole thing fits together. The task is pretty clear. Develop a way to handle the sequencing and timing. And what does it depend on? Well, stage 1, of course, the very layers we just defined. It's common sense, really. You can't make a schedule until you know what you're scheduling. It's just a clear step-by-step process. All right, the foundation is poured. Now it's time to install the heart of the system, the dynamic, self-improving core. Let's call this section the engine, because it's all about feedback and getting better. Stage 3 is all about integrating feedback loops. The best way to think about this is like installing the system's nervous system. It's how the whole architecture is going to feel and react, and most importantly, how it's going to learn from its own performance. So the really crucial point here is that we're not talking about one big feedback loop for the entire system. No, the task is to integrate these loops within each individual layer. This allows for really specific, fine-tuned learning. And of course, this whole thing depends on the timing we set up back in stage 2. You've got to have the right sequence of events to get any meaningful feedback. Okay, now for stage 4, automated improvement cycles. The system has its nervous system. It can feel when things are going right or wrong. Now it needs a brain to process all that information and actually act on it without a human having to step in every time. And this is where the real magic happens. This is where the intelligence really kicks in. The whole point is to set up automated cycles that actively use the feedback from those loops we just built. The system is literally learning to make itself better, and it's all built directly on the work we did in stage 3. It's not just taking in data anymore, it's using that data to improve. We've built the foundation. We've installed the engine. Now it's time for the final act, the part where all the individual pieces come together to work in perfect harmony. I like to think of it as the final symphony: synchronization. This brings us to our 5th and final stage in the blueprint: layered cognition synchronization. This is that last critical check to make sure the entire thing isn't just a collection of parts, but a truly cohesive, functional whole. And as you can see, our conceptual architect, phys-la-meta, is overseeing this final task. It's all about ensuring every single layer is in sync. Now, this stage depends on those automated improvement cycles we just talked about. Why? Well, it's because the system needs to be able to correct itself and make adjustments on the fly to maintain that harmony. This is what ensures the final product is not just stable, but truly intelligent. So, we've walked through the 5 stages of the architectural blueprint. It all sounds good in theory, right? But how does this master plan actually move from a concept into a real practical thing? Let's take a look. This table lays it all out perfectly. See, layer identification isn't just a vague idea. In practice, it means you actually document each layer and what it's supposed to do. Temporal coordination becomes a real timeline and a scheduling system. Feedback loop integration means you set up the actual tools to collect that feedback. Automated improvement, well, that requires someone to create the algorithms that do the analysis. And finally, layer synchronization means you implement monitoring systems to watch over the whole thing. It's a direct, actionable plan. And what do you get when you follow these 5 deliberate stages? The result is a fully synchronized, self-improving cognitive architecture. You get a system that isn't just built and then left alone. It's designed from day one to grow, to adapt, and to become more and more effective over time. So this blueprint really shows us a path to building a system that can learn. And it leaves us with one pretty profound question. Once a system can think and learn and improve all on its own, what will it decide to build next?